Right, so now let's start with the first example. So I'm going to start with a very simple one. I'm going to find the Laplace inverse of 6s minus 5 over s squared plus 2s minus 15. If you notice right here, we have a quadratic expression at the top because the highest power is going to be s to the power of 2. And of course, we can only use this when you can actually write your fraction in terms of factors. If it cannot be factorized in terms of this, then you cannot use partial fraction. So therefore, according to what we have over here, if I were to factorize this, I'm going to end up with something like 6s minus 5, and that is going to be over, so that is my 5. Let me put that properly so it doesn't confuse you. This is over minus 5 over, when I factorize at the bottom, I will end up with s plus 5 multiplied by s minus 3. Okay, so that is going to be how my fraction look like after being factorized. And now that I already have like multiple factors over here, the multiple because we have like more than one factor, I have 2 factors in fact. So I'm going to decompose the fraction into partial fractions. And as we have seen before, because the power of the outside of the bracket, this is to the power of 1, this is also to the power of 1. So I'm going to end up with 2 partial fractions. So the first one is going to be over s plus 5 and the other one is going to be over s minus 3. And because, so the power of, so this is supposed to be our bracket, the power of s inside the bracket are both to the power of 1. So that is why I'm going to end up with a constant of a and b at the top. So when you use partial fraction, so the next thing that you have to do is you have to find the value of a and b. You cannot leave it in terms of a and b. You have to know for sure what is going to be the specific value for a and b for this case. And how are we going to do so? So this is what I'm going to do next. I'm going to make the left and right have the same denominator. So on this side, I'm going to have 6s minus 5 over s plus 5 s minus 3. So this is our original fraction. And then on this side, I'm going to make the denominator equal. This also should be s plus 5 multiplied by s minus 3. And I'm pretty sure you have seen this before. This is simply going to be cross multiplication because we only have 2 factors. And in order to make the denominator equal, so at the top I'm going to have to multiply this by s minus 3, and b I'm going to have to multiply by s plus 5. Okay, so now notice what happened is that our denominator at the bottom, they are the same. And of course, because this is equal, if the bottom is the same, automatically the top is going to be the same as well. So we are going to use the equation at the top in order to find the values of a and also b. So now let's start finding the values. So I'm going to have that 6s minus 5. That is going to equal a multiplied by s minus 3 and plus b multiplied by s plus 5. There are actually 2 ways of finding a and b. So let me put a remark over here. So there are 2 ways of finding a and b. So you can either use either of these methods. So which one are you more comfortable with? So both of them are going to give you exactly the same answer. A, not a or b, a and b. Okay, so the 2 methods are, one is called as the substitution method and the other one is called as the comparison method. I'm not sure like previously when you have been introduced to partial fraction which method you actually apply, but I think that knowing both of them are going to be very helpful for you because there are certain cases, or we are going to use both for complex cases. And of course, when you solve your differential equation, your DE, by using Laplace, so the most common way to find the Laplace inverse is actually the partial fraction. Or use both for complex cases, right? So you have to know this very well, and it is very helpful when you can actually use both methods, substitution and comparison, because I would really suggest that first use substitution to find some of the values, and those values that cannot be found by using substitution, then you can use the comparison method. So it's going to be easier that way. Okay, I'm going to show you both of the methods actually. So if you have seen this before, you already known this already, so no need to actually have a look at this video in detail, so you can actually skip those. But for those who think that you need to revise on this, so please listen very carefully. So I'm going to show you both method, substitution and comparison. So I'm going to start with method 1. So let's use, let's put comparison as the first method. So method number 1. So I'm going to use comparison in order to find the value of A and also B. So method 1, comparison. So let me rewrite the equation again. So we have an equation of 6s minus 5 is going to equal A. So A is being multiplied by s minus 3. And then I'm going to have a B. So B is being multiplied by s plus 5. Or it doesn't really matter. Like when you write your partial fraction, you can also write it the other way around. So it's going to be A over s minus 3. So this is actually the same as having A over s minus 3 plus B over s plus 5. So they are the same. Okay. So there's no problem. Like whichever you write is going to give you exactly the same answer at the end. I don't know why, but when I look at my 5, they always look like 6. So be careful with that. So this is actually not a 6, it's a 5. It's because of the pen. Okay, so now let's use comparison method. Okay, how are we going to apply comparison method? The idea will be the same as the undetermined coefficient. Remember when we wanted to identify the value of C, D, E, F in undetermined coefficient? So what we did is we start with the highest power. For example, like we start with x to the power of 2, x to the power of 1, and then x to the power of 0 for the case of polynomial. And this is going to be exactly the same method, right? So all you have to do is rearrange it according to the power. Okay, if I rearrange this, I am able to write this as 6s minus 5. I know that the highest power is going to be s to the power of 1. If I were to factorize and put together the term with s to the power of 1, I'm going to end up with, this is going to be as. So I'm going to have a plus b. And the rest of them is going to be negative 3a plus 5b. So these two, do not get confused, these two are actually just the same. I just rearranged them. Okay, that is all that I did. There's nothing confusing about it here. Right, so now that I already rearranged them, I'm going to start comparing with the highest power, which is going to be s to the power of 1. So on this side, my coefficient of s to the power of 1 is given by 6. And on this side, it's given by a plus b. So I'm going to have that a plus b, that is going to equal a value of 6. And then I also have s to the power of 0. So that will be referring to all constants that are not related to s over here, which for this case is going to be negative 3a plus 5b. And on this side, they are going to equal negative of 5. So please do not miss out the negative. So negative of 5 should be there. I always mention this to my students. Actually, at this step, you don't have to do the calculation in full. You can simply use your calculator for this. And I think that is a very important skill for you to know how to use the calculator in order to find the value of A and B for this case. Because first, it guarantees that your solution is definitely going to be right. And you know that the calculation is going to be like super long. So using your calculator for that, it's going to be like a very clever, very wise decision because it saves a lot of your time. Okay, so now, of course, how do we get this? This is going to be from simultaneous equation. Okay, I'm not going to show you how to find these values. You figure out on your own. Like use your calculator, do it by hand. So any other method that suits you, and you will be able to get that A, the value is going to equal 35 over 8, and B, so the value is going to equal 13 over 8. So those are going to be my values for A and B. And of course, if you write A and B the other way around like this, if you're using this over here, automatically your answer is going to be A and B is going to be the other way around. But they are both correct. Okay, so now that I already figured out what is going to be the value of A and B, all I have to do is I have to substitute back into the equation over here. Here, I'm going to have to substitute in here. Okay. So I'm going to write that. So the fact that actually, if I were to Laplace inverse, so a function of, what is my function? So that is 6s minus 5. So if I were to Laplace inverse 6s minus 5 over, so s plus 5 multiplied by s minus 3. So this is actually equivalent to Laplace inversing of So let's write this at the bottom. It's not going to fit. So this is equal the same as finding the Laplace inverse of, so I'm going to substitute into this equation, right? So A, so what is going to be my A value? So my A value is going to equal 35 over 8 over s plus 5 plus B, and my B value is going to equal 13 over 8, and that is going to be over s minus 3. And of course, you can apply the linearity theorem. And when I apply the linearity theorem, so this is going to equal, so 35 over 8 Laplace inverse of 1 over s plus 5. So now this looks less intimidating. And then I'm going to have plus 13 over 8, and that is going to be a Laplace inverse of 1 over s minus 3. Now, if you notice, like this too, this can easily be found by using table. So that is why we do Laplace partial fraction. From a very complicated fraction, so we make it into smaller fraction that can now be easily inversed by using the table, for which I'll end up with 35 over 8, and this is going to be s to the power of 1 followed by constant. So it's going to be exponential of negative 5t according to the table, and plus 13 over 8. Now I'm going to have exponential. Remember, it's going to be the inverse. So because this is minus, I'm going to have exponential of positive 3t. That will be the end of the calculation. Okay, however, that is using the first method, which is going to be comparison. So let me show you the second method. Like the end will still be the same, like you Laplace inverse those. But how do you find the value of A and B is going to be different. So method number 2, instead of using substitution, so I'm going to use the comparison method in order to find the value of A and also B. This is the comparison method. Sorry, this is not comparison method. It's suppose method number 2 is going to be substitution method. Okay, so it's going to be the same idea. So I still gonna have the same equation, and my equation is given by 6s minus 5, and that is going to equal A multiplied by so let me have a look back at my equation, s minus 3, and B is being multiplied by s plus 5, right? So that is my previous equation. And now if I wanted to find what is going to be the value of A and B by using substitution, so you have to bear in mind, what you're going to have to do is you have to choose an appropriate value of S. Okay, how do we pick the value of S? Okay, how to choose the value of S? So the answer is you're going to pick the value of S from the linear factor only. Okay, slide to highlight over here. So linear factor only, right? So for example here, so this is a linear factor because I have here s to the power of 1, and this is also a linear factor because this is also expression with s to the power of 1. So those are called as linear factors. And the value of s that you're going to choose, they are going to be from this linear factors. Okay, so how are you going to do that? Alright, so from the first linear factor, so I'm referring to this one. So what you're going to do is you're going to set the expression as being 0. So s minus 3 is equal 0. So that will be the case when s is equal 3. So that is why s equal 3 is going to be the first value that we're going to use for substitution. And then we also have this other linear factor, which is going to be s plus 5 equals 0. So our value of s is going to equal negative of 5. So that is going to be the second value that we're going to use. So where are we going to substitute these values? We're going to substitute these values right here. So everywhere there is s in the equation, so substitute that the values of s equal 3 and s equal -5 into them. Okay, so let me write over here. No, not from here. Yeah, substitute values of s into this equation. Okay, so let's start with the first one. So for the first one, I'm going to substitute this with s equal 3. Okay, so you see the part where I highlighted all s in yellow, so that is going to be substituted by s equal 3. So my equation is now going to be 6 multiplied by 3 minus 5, and I'm going to end up with a 3 minus 3, and then I'm going to have plus b multiplied by 3 plus 5. Okay, so this is what we wanted to happen, that certain terms, they are going to become 0. So now from here straight away we will be able to get what is the value of b. When I simplify this side, I will have 18 minus 5, so that is going to equal a 13. I will end up with 13 is going to equal 3 plus 5, that's an 8. I'm going to have 8b. So straight away we can tell b, the value is going to equal 13 over 8. So that is exactly the same as value that we got previously, that b is going to equal 13 over 8. Okay, so that is our first substitution, s equal 3. And now I'm going to substitute the second value. So the second value is when s is equal negative of 5. Okay, when s is equal negative of 5, so my equation now is going to be 6 multiplied by negative of 5 minus 5. The idea is still going to be the same. I'm going to substitute wherever there is s in the equation by s equal negative 5. So I'm going to have a multiplied by negative 5 minus 3, and then I'm going to have plus b. This is going to be negative 5 plus 5. Again, if you notice what happened right here is that this term at the back, so this is going to equal 0. So straight away I will be able to find what is the value of a. When I simplify it, I will end up with negative 35 on this side. So negative 35 is going to equal negative 8a. So therefore from here I will be able to get that the value of a is going to equal 35 over 8. That will be the value. Okay, so therefore when we write our partial fraction, we substitute the values. So it's going to be the same as before. I'm going to end up with Laplace inverse of a, which is 35 over 8, and that is going to be over s plus 5. And the other one is going to be b, which is going to be 13 over 8. That is going to be over s minus 3. And of course, so it's going to be the same as what you have seen previously. By just simply using the table, it's going to give you exactly the same answer like this. So basically, this is just two methods that you can pick between. So if you're happy to use substitution, use substitution. But if you think that comparison is going to be much easier, then you can use comparison instead. And again, let me remind you that you can only find the value of s equal what value. So that is only from the linear factor. If there is a quadratic factor or a cubic factor, then it is not possible. You can only use that, and you can only use linear factor in order to find the value of s to substitute. Right? So the next two examples, I will continue that in the next video.